It's alright, right? The microphone. So Gevent, it's a networking library, coroutine-based networking library. It used to write network daemons, network lines, web applications. It has a WSGI server, so it works well with most of the Python web frameworks available. It's a small library. It doesn't tend to include all possible protocol implementations into it, except for the most basic ones like DNS and HTTP. But it can be as useful as larger frameworks with lots of features because it has an ability to run networking code that is already there in the Python standard library, or any Python package that is written for Python sockets. It's a relatively young project. It started 2 years ago as a rewrite of Eventlet. Both Eventlet and Gevent provide lightweight, cooperatively scheduled so-called green threads that feel like they built into the runtime of the language rather than being a library feature. The magic that makes it possible is available in Greenlet extension. This is a C Python extension. Greenlet uses some of the stack switching code from stackless Python, which is a separate distribution of Python, or it supports of coroutines. Gevent uses Greenlet, but it can also be made work on stackless. There's also movable now to movable. The next major version is going to be 1.0. I replaced the event loop with sleepback. I've replaced the resolver with DNS with CRs. The end result is that it works much better now. The changes are mostly internal, so migrating your application shouldn't be a problem from Gevent 0 to Gevent 1. And the annoyances that we had in Gevent 0, like Python signal module didn't work, resolver ignored etc hosts and etc resolve, they are gone in this unreleased version. The internals that I'm going to describe how the internals work in 1.0 because there have been some cleanup and it's just easier and nicer to explain. So the plan for the talk is to introduce coroutines and the use case for them in the context of the networking application. Then once we have coroutines, I'll explain how Gevent works, how it uses them. I will go briefly through Gevent API and then we'll cover some of the community contributions. So if you want to make a networking application, you have two choices. And whatever you choose affects the design of your application from bottom to top because, unfortunately, it's not the low-level details that you can just hide behind a nice abstraction. The first choice is simpler. Blocking sockets means if you call connect, it actually connects and then returns to the caller. It means that it does some I/O before returning, and that might take some time. Most of the standard library uses blocking sockets. Most of the web frameworks depend in one way or another on blocking sockets. There are a lot more packages in PyPy that use blocking sockets. If you want multiple connections with blocking sockets, you need to use multiple threads, and it might be a good option for your app, especially if the number of threads is small. It has an advantage of being portable. You don't need additional packages like Gevent. The OS threads are preemptive, so you need logs to protect the shared data, and you need the libraries to do the same, or you need them to be thread safe. The threads are a bit memory hungry. The stack is allocated up front about several megabytes, and that puts the limit how much threads you can create on 32-bit machine before you run out of space, in the ballpark of 1 and 2,000. Also GIL, and that can have interesting effects on multi-core because of GIL contention. Performance can become worse on multi-core than a single core. Most high-performance stuff in Python world and outside Python world uses non-blocking sockets. With non-blocking API, you call a request, you make a request to some socket API, and it only succeeds if the answer is available immediately. If it's not, you expect it to retry the call when the descriptor is ready. And there are a number of syscalls available to check for descriptor readiness. Select poll equal AQ. EPOL and KQ are especially interesting for networking apps in general and for web applications because they scale well with the number of total connections. The algorithmic complexity is proportional to the number of active descriptors, not the number of total descriptors like is the case with Slack and POL. So the application become much different now. The chat is now owned by the event loop, which continuously calls for descriptors and executes a callback. The application is actually a set of callbacks that subscribe to events, supply callbacks, says call me later when this happens. Yeah, it's in this callback you must be really quick, otherwise you will block the whole thread, the whole event loop. So you cannot use all the nice blocking stuff like available and steadily, and you cannot use most of the web frameworks. This is the reason why, say, Twisted and Tornado came with their own web stuff. So what Gevent offers you is a sort of mix of the two approaches with benefits of the two approaches. The green threads are scalable as callbacks, but they switch context only at I/O points. These are cooperative threads. That means that you can avoid locks most of the time, you don't have deal problems, and you can even use it as a drop-in replacement for your multi-threaded application. And that's what coroutines for. But what is a coroutine? If you look at Wikipedia, the definition is a subroutine that can be paused and resumed. But that definition is kind of broad. Even in Python world, there are three very different implementation of coroutines. For example, multi-shot coroutines is a kind of coroutines that you can pause and resume, but then resume from the same point multiple times. You can even pickle the coroutine and then unpickle it on different machine and resume there on several machines. Stackless Python has those kind of coroutines. Symmetric coroutines are the kind that yield to the parent, always yield control to the parent. Python generators are example of symmetric coroutines. Asymmetric coroutines, you will specify which coroutine you want to switch to. Greenlet, for example, is an asymmetric coroutine. You always say, I want to switch to this greenlet. This difference actually equivalent in power. If you have one, you can build another. The most important property, and that's what makes Gevent wonderful, is whether your coroutines are stackful. Stackful coroutines have an ability to save the whole stack, while non-stackful coroutines, like generators, can only save a single frame. That means you have to know in advance whether the thing you call is a generator or a function, and you have to do yield at all levels. You cannot hide it behind a function. You cannot use standard library modules. You cannot use web frameworks. Basically, you only got synchronous execution, but a number of traits shared with non-blocking approach. Greenlet, on the other hand, is a stackful coroutine. So you can call a function, and that internal function does switching, and then the whole stack is saved. This is a much more powerful abstraction, and we use that in Gevent. So what happens when you switch from a greenlet? This is your stack. It has Python frames on it, it has C frames on it. When you just create a greenlet, not much happens, just object get initialized. But when you first switch to a greenlet, it remembers its position, the current position on the stack, and marks it as stack stop. Then you, okay, it was. Should I talk here or here? Both? Then when you switch back, this stack segment that is devoted to the latest greenlet is saved on the heap, and then stack pointer is reset back to the original value it has before switching to this new greenlet. So now you have G1, which is inactive and on the heap, and you have stack which is in exact same state as it was before switching to greenlet. So to this parent greenlet continuous execution. Of course, it can now grow its own frames, and that also needs saving, but the greenlet module does this clever bookkeeping to make sure it all works out all right. This is quite fast. On this laptop, I can create, switch in and switch out 60,000 greenlets per second. Of course, these are trivial greenlets, and the bigger your stack, the more memory you need to move. But still, switching is usually the small part where application spends time on. Unlike threads, which require allocating the stack up front, it uses the memory efficiently, only allocate the size necessary. The stack switching is done with some assembler code, and this assembler code is written per platform, so the portability is somewhat limited. If you use Greenlet and you want to make cross-platform app, you should check on all the platforms you want to deploy. Usually not a problem for several applications, and the majority of the platforms are supported. There is another problem that there's a structure called by-thread state, and it is shared between greenlets. So if you an exception handler and you switch into another greenlet, the new greenlet will see the exception that you had before. But luckily in Gevent uses greenlets in such a way that we can walk around about that state and restore the proper exception information for you. The portability concern can be addressed somewhat with swap context API. This is a POSIX API to do this kind of user-level switching. Swap context doesn't do this stack slicing, but instead it also requires you allocating the memory to stack up front, so it has memory requirements comparable with threads, but still it's user-level threads and might be faster for your I/O applications. It also happens to be slower than Greenlet because it does a syscall per switch. There is a really small subset of Greenlet implemented swap context, mostly for benchmarking, not for me, but this Mike Barton, I think. And he did the checks. So now we have the powerful abstraction called coroutine, and we can use it to create Gevent. So the core Gevent is also as an event loop, like any other non-logging framework. We use event loop written in C called liba. It's actually a new in 1.0. Before that we used liba1. And it's not aware of greenlets. It's callback stuff, like you have in Twisted, for example. So liba provides you with all kind of watchers, level trigger, IO notifications, timeout signals, idleness notifications. And you can start the watcher, pass a function, and it will call it when this function, when that event happened, that this watcher watches. The main difference with this API from the last version is that function is part of path to start, and that means that we can clear it and stop, and that removes ref counts from ref count and cycles from Gevent. So this new version has an advantage of not creating any ref count cycles. So with this non-blocking frameworks, take control of your thread. With Greenlet, you can take control back. What you do is you run the event loop in a special dedicated Greenlet. It's called hub. It's created lazily by the initial Greenlet. When you first use Gevent API, it creates hub, initializes event loop on it. Hub is a Greenlet, so you can switch into it. The interesting method that the hub has is wait. Wait is a method that you pass a watcher to it, and then it switches out the current Greenlet until that watcher has gotten the answers. For example, if you want to implement cooperative sleep, you just post a timer and initialize with a number of seconds, call wait, and that gives you cooperative sleep. This makes the current Greenlet sleep for this number of seconds. The wait implementation is also very simple. Just switch to Greenlet, but before you do that, establish a callback to switch back. The actual implementation is a little bit more complex. Not much, but what it does is it checks that switch is legit, that it's really the switch that we scheduled and not some other switch from some other misbehaving greenlet. It's not really strictly necessary if you just use Gevent API, but it's good to have there because the problems that you get if you switch wrongly in some greenlet are really annoying. You don't have a right traceback, you have traceback that's unrelated. Early event lab has those kind of problems, and this was really frustrating. So you have cooperative sleep. Now you can implement cooperative socket. What's cooperative socket? It's a kind of socket that looks like blocking socket. We solve the blocking method, but actually wraps a non-blocking file descriptor. So when you call receive a non-blocking file descriptor, it can fail with retry again error, or it would block. That's no problem. We just call wait function with IO watcher, and then we pause the screenlet until the descriptor is ready and try again. Actually, this indentation is failed, but it's you. So in that manner, we implement all of the socket module, not only socket object, but also all DNS functions. We use CRS for that, so when you call blocking DNS function from Gevent socket, it actually does asynchronous resolving of a name using CRS, and then formats the result in such a way that looks like you code regular get added and call get close by name. There are also SSL object, and there are also even a select function, which is sometimes useful in tests. This is a complete example. First we do monkey patching. Monkey patching means you replace the standard socket with this cooperative socket. Then you can use the libraries that use the socket. For example, URL lib2. Here you just found an additional greenlet to do compare and download of two pages. Looks very much like 3D solution. So you call monkey patch all. It replaces socket, SSL, sleep, select, all the things that it knows about. It also replaces threading functions to make them greenlet based. So you have a multi-threading application doing monkey patch all is enough to make it greenlet based. People sometimes avoid doing that, but there really no reason to not to have a blocking socket in your Gevent program, because even if you think you don't use the socket, some library might, and when it does, it will block your complete application. People want that. So you've seen the Gevent spawn function. This is just a shortcut for creating a greenlet and starting it. This greenlet with capital G is a subclass of that low-level greenlet, so it also has switch method and draw method, but you never use those in a Gevent application. It also has some methods you would expect from a thread or process, like wait for it to complete, or raise an exception on it, and then wait for it to die. Most of the API in Gevent is like that. It does something, and then it waits for it to complete, like join here or kill. Start is an exception, it's asynchronous. If you want to limit the time it waits, you can, in most cases, just pass timeout parameter. If that's not enough, you can use timeout class to implement your own timeouts. In the first example, if this little piece of code doesn't finish in 5 seconds, the timeout exception is raised. In the second example, with the false in the second argument, not only timeout exception is raised inside the with block, but it's silenced outside, so it seems like people just interrupted after 5 seconds. Of course, timeout are regular exceptions, so they can be called by except all clause, and something you can't do much about, except inspect your code and check that it doesn't do that. It also cannot interrupt the code that is CPU busy, that doesn't yield to the hub, but you can use SIGLR for that if you really want to do something like that. The pool class is for managing greenlets in a group. It also has spawn method, and when you call pool spawn, the greenlet becomes part of this group. A pool can have a limit of how many greenlets it can pass. For example, this has 10,000, and when it reaches 10,000 active connections, it starts active greenlets, which are in this case the connections. The spawn just blocks until there is a free slot. The API of the spawn of pool is inspired by multi-processing pool. There are lots of methods like IMAP on order that's already present in the multi-processing. This is actually not a good way to implement the server. It has a number of flaws. So you can use the stream server plus, which will spawn for each incoming connection a new greenlet, and it's very easy to create your own servers. You can even use it with pools. Just pass it the pool argument, and it will use the pool to spawn greenlets. It can wrap your connection in SSL if you pass the relevant arguments. There are a number of classes to do asynchronous and synchronous communication between greenlets. Almost all of them have the API inspired from the Python standard library. If you use Threading, you know event, you know queue, priority queue, to enable queue. There are even logs, although in most cases you don't need logs. Sometimes you do. For example, if you have a WebSocket implementation and you want send method, you might want to add a log to send method so that there are several producers and they don't conflict with each other. It doesn't make sense for streaming-based protocols, but WebSockets are message-based. So it makes sense. It makes sense. We also have Whiskey server. In the 0 version, there are two of them. One is the fast based on Gevent server. Another is EuroPython that has more features. One of the features that's missing from Gevent is keep alive. So in the 1.0 version, we kind of lack this fast server because we don't use Gevent, and maybe we won't at all. So this is something that needs to be done. Now this is just an in-process server, and if you want to deploy it, there is a pre-fork server called GUnit. You just say, this is my application, I want to use Gevent Whiskey, I want a number of Docker processes, and it runs the application in this multi-process environment. As I said, you can use all the modules implemented in Python sockets. For example, I use Redis with Gevent every day, but most of the database drivers are in C. So you cannot use MySQL DB, but there are a few drivers written specifically for Gevent by a company called ESN that use Gevent. PsychoPG2 is a wrapper for C libraries that works with Postgres. It has generic support for coroutines. What it does is that it can call your callback that blocks until the descriptor is ready. And you just apply a small function and it's automatically support Gevent. There are a lot more interesting third-party contributions. There is WebSocket protocol implementation, Socket.io backend. Socket.io is WebSockets implemented a lot of different transports. HTTP load testing tools, proxies, TCP proxies, HTTP proxies. There is integration with zero message queue, and people love doing stuff with zero message queue. There are, for example, some distributed map previews, fast GAIA-inspired task queue, and there are more projects on GitHub. I just don't keep up. People love use SerenQ and the Gevent together. If you follow this URL, there's some more or less complete list of the projects that I maintain. This is one of the users, of the early users of Gevent. This is information from the owner about how they operate. So they used to use Twisted in a single process, but when the number of connections reached 5,000, the performance became slow. So he wrote it in Gevent and was able to scale the single process until about 10,000 connections. Now he has multiple servers, which are mostly idle, and the estimation that they use 60 kilobytes per connection. So the plan for 1.0 is to provide this fast Whiskey server, which is currently missing. Also, documentation is lacking. A few more features that I think would be nice to have, but they don't necessarily block the release. So to summarize, coroutines are easy to use easy to use threads. It could be as efficient as any other non-blocking solution. As any other non-blocking framework, it works well if the application is IO-bound. Gevent tries to beat the standard way to do greenlet-based stuff in Python, so it uses all the standard API, event, queue, all that stuff. And it works with socket. A module is written on top of socket. Well, thank you. Hope you got any questions.
Okay, there's a lot of time for questions. Anybody has a question?
Hello. I'd be interested if the application which I want to rewrite for Gevent has to be thread safe, because it doesn't seem to me like it has to. But are there any limits? Like if I have, yeah, that's my question.
In most cases, you don't need to be thread safe. You need to be greenlet safe. That's just a much more relaxed requirement than with threads, because greenlets only switch at the certain points. You know that this operation is atomic most of the time. So most of the time, in practice, you don't need to do anything. Maybe sometimes you do, but that's really rare.
You're not going
And another point is that it's already thread safe and it's already greenlet safe.
You're not going to have a problem incrementing an integer, but you'll be exposed to race conditions and all sorts of concurrency problems. That would be nice. Any other question?
I was wondering if you use the database drivers, will it also work in ORM, such as SQL?
Well,
SQL Alchemy?
SQL. I haven't, but there are reports from users who have. But in the early days, they used MySQL connector with MySQL database because there were no C written in C drivers. And some people report that they did that. I have.
There were some limitations in the two different WSGI implementation on the previous version, and I wanted to know if they disappeared in the 1.0 version, and why they are still there if they do.
Oh, I don't want them to disappear, but the question is whether to continue use libEvent HTTP server, which we still can do even though we switched to event loop, or whether to write something new. If we write something new, it will be much better than the old one.
There's a question here. Can you pass the remote row?
So, why would someone choose Gevent over EventLet?
Why what?
Why would you choose Gevent over EventLet?
Or EventLet?
Yes.
Oh, there are lots of reasons, but I don't even know where to begin.
Best reason.
Well, one of the reasons that there was made a right is that having one event loop makes it, lets you debug it much better than with all kinds of different event loops. Actually, I was working on PyEvent hub for EventLet, and I couldn't make all of the hubs work together. It's just too much work to make sure they're all the same in all little details. So I just dropped everything else and rewrote some other stuff that I didn't like. It's just a library, what can I say?
Any other question? No? Is it covering certainly a million questions?
Which minimum version of Python does it require?
If you have reduced to the 5, you will be fine. Actually, for Gevent 0, I haven't supported 2.4. But I'm not sure if I tested it in the latest release. But 2.5 should work okay.
How easy or hard is it to integrate GN with the GTK event loop?
A GTK event loop? You mean completely use GTK event loop and don't use any event like Figure stuff?
Yes.
Well, with the 0 version, it's impossible. With this new version, you can provide your own implementation of event loop. I don't know how it's easy because the interface is really inspired by Libot. But you can sort of imitate that and it shouldn't be that hard.
The question?
Is there some new frameworks that are based on Gevent? I mean HTTP web framework, or adaptation or existing ones?
Web frameworks like Django, this kind of framework?
Well, I'm not sure Django can be asynchronous, maybe with some work, but there are some work going on with. I mean, because Gevent is very low level, and is there some web frameworks that tries to leverage Gevent to provide something more easy to use?
Web frameworks can just use Gevent as a replacement for multi-threading. I don't know of any web frameworks that uses Gevent API, but it seems like it's 2 different levels. Gevent just gives you green threads and sockets, and web frameworks just use whatever sockets they have and whatever threads they have.
I think he means to say that it's going to transparently use Gevent.
Yeah. So if you have asynchronous drivers for your database and stuff, it's okay.
Yeah.
All right.
Any other questions? One?
What about the possible PyPy integration?
As far as I know, PyPy has separate branches for stackless support and for G. So I think with stackless, the hardest part is greenlet. If you have that, then you can make something on Gevent. So on that version of PyPy that supports stackless, you can have it. On that doesn't, well, right now you can.
Any more? Last call? No. Okay. Next talk is Armin Ronacher, if I'm not mistaken.